What's up? Have you seen these amazing pieces of like AI generated art on the web? People doing like amazing avatars and things of themselves. I've done some myself. Here's a few. How does that work? And more importantly, do you need some big, beefy graphics card? Do you need a data science background? Is that like a hard prerequisite for you to make your own? Let's talk about that. So Stable Diffusion is the word, right? Stable Diffusion is a text-to-image-based machine learning model trained on an enormous amount of image data from across the internet that is able to synthesize images based on textual prompts. So you're like a scenery of dinosaurs playing golf on Mars, and then it will just draw it for you. It's pretty cool. I suspect, I don't exactly know the details because I'm not a data science specialist, but I think I heard people say it started from wanting to just like fix noise in images to make them more clear. So if an image is noisy, like this, then you have an AI like make it clear by working through noise, diffusion noise. And then you amplify that times a million and you just present literally just like latent diffusion and an image appears. That's where we are. Like if I think about, imagine how nuts this is. It's like as a human being, you look up and you look at clouds, you're like, ooh, clouds, diffusion of water vapor, right? And then you're like, ooh, that cloud kind of looks like a bunny. And then it's a bunny, you know? It's wild that we live in that today. So that's Stable Diffusion, and it's been around for a while, but then Google made another machine learning model that can fine-tune Stable Diffusion and like tailor its results based on input data. That's called DreamBooth, and it's literally like a photo booth that's able to like dream up you in different scenarios. You fine-tune Stable Diffusion using DreamBooth with input images, and then your DreamBooth model is like personalized to you. You could generate yourself as Spider-Man, as Morgan Freeman, on the moon, as a cyberpunk person, as a Giga Chad, as a Fortnite character, whatever. So in this video, I want to talk to you about how it all fits together, and I just really want to give you the powers to make your own Stable Diffusion and DreamBooth style images and show you how to do that. It's free and you don't need a programming background. It's of course one of the ways. There's proper ways to do it where you have like supercomputers and all the machine learning experience. If you don't, this is the video for you, okay? Let's just dive right in. So here, let's come to the computer. This is where we're gonna be, and this is what we're gonna be using. The Last Ben / Fast Stable Diffusion. The Last Ben, listen, if you want to support anyone on Earth, it's The Last Ben. This dude is making Stable Diffusion and DreamBooth accessible to so many people and really enabling people and bringing down barriers of entry. This is what I'm about. This is what I support. This is what I love. So The Last Ben, I'd recommend. He's got a, here we go. He's got a coffee page, code-file. I'll put a link under the like button. If you are so inclined, donate, give him some support because his work is very, very good. In fact, here's what I'll do. Every amount of money for every cent that I get from this video from YouTube, 30% of it straight to Ben, straight to The Last Ben, because the work is that good and that valuable, okay? So The Last Ben created this collection of notebooks that you can open in Google Colab, which is an interactive notebook-like experience, and just run through the flow and train your own DreamBooth images. So I'd like to show you that, but if you're not sure what Colab is, maybe we should just take a quick segue and talk about what notebooks are. Colab is kind of like Observable HQ, Observable Notebooks, and if you don't know what that is, I just show you. So if we come here, this is what Observable looks like, and it's literally, it's like this. It's a interactive notebook. But let's actually use it. So I'll sign in, Tejas K, and I'll continue with Google. And let us go. Wow, that really puts me off the loading spinners. Anyway, so we'll create a notebook here. A blank one is fine. And I just want to show you what notebooks are like, because they're like literally like notebooks, but you can execute code interactively. So we'll say my notebook, and that's that. We'll add a JavaScript snippet underneath. We'll assign a variable. My variable is, I don't know, let's fetch some data from my favorite API. Dog.ceo API breeds image random. We'll serialize that to JSON, and let's see if that works. See, so you can execute code like inside the notebook. Excellent, that works. Now I have variable. Let's rename variable maybe to good boy image. Let's do that. And really, I'm just interested in the message of this. So when the JSON resolves, I'll do, you know, thing.message just to get that message. And now, awesome. So my good boy image has a URL. Let us render this. So I'll add another JavaScript snippet. I will use a tagged template literal for HTML, and I will just do this. I'll do image alt good doggo src, right? And I will interpolate my variable good boy image. And if I run that, right, so I have it. Is it random every time? Probably not, because I'm assigning the variable once. But if I play this again, I get a new one, and then this changes. So they're these like responsive notebooks that you can then execute code in. That's what an interactive notebook is. Jupyter Notebook's another platform, Google Colab, same thing. So the last Ben has created a notebook like this where we can sequentially go through steps and train our own DreamBooth models. Let's do that. So this is what Colab, I said CodeLab, huh? This is what Colab, Google Colab looks like. Welcome to Colaboratory. What we're going to do is go to GitHub and load the last Ben. We're going to load his thing. So let's do that. I'm going to hit, I just muted. I'm going to hit enter, and we'll choose the fast Stable Diffusion repo and choose fast DreamBooth. And now it's going to open that for us. You might want to save a copy because, you know, just so you own your thing. And now we can do it. So step one, connect to Google Drive. We need to take a quick pause because before we get to actually working this, there's some prep work we need to do for our DreamBooth model. You see, because it's trained on like images of you as a person. So we need to get those images from somewhere, okay? How we can do that is you grab your phone, okay? And you take pictures of yourself. So you open your selfie camera, make sure it's a square, and literally like a close-up straight on, a close-up from the side, another close-up from the side, a close-up from down, close-up from up. The only hard rule is really it needs to be a square, it needs to be high quality, you need to be in the center all the time, and your two eyes need to be visible in all the pictures. So close-ups, some mid-range shots with your torso, maybe some full body shots. You need 30 pictures, of which I would say like 70% have to be close-ups of your face, and the rest can be a bit more range for, applying that to some models, okay? To some images rather. So you're going to need to take those pictures, about 30 of them. They're going to need to be squares, and then you're going to need to resize them. If you want to resize them, there's a great tool called BeerMe, bulk image resizing made easy, and you just drag all your images in there, drop them, and you're good to go. Once you have 30 512 by 512 small images with you in the center, you're good to go. I have this. If you want to take a look at mine, let's see, there's a bunch of stuff here, but I'm more interested in downloads, and there's a lot of stuff. I think these are my, so these are my pictures, my reference pictures. And yeah, so it's just, mostly me with a very angry expression. But yeah, that's 30 of them, okay? And they're squares, so if yours looks something like this, you're good. So you're gonna take those, and then you're ready. Then you can go through the Colab, not CodeLab, Colab notebook. All right, let's do it. So go here. Step one, connect your Google Drive. Let's do that. So I'm gonna run anyway and connect to my Google Drive. Now you might be thinking, why does it want to connect to my Google Drive? And it wants to connect to your Google Drive because this thing keeps its state in your Google Drive. It's pretty awesome. So then it stores everything there, and you can pick up where you left off after you exit and so on. It's very great. And it's much better to store this on your Google Drive than on someone else's things, because it's pictures of you. It's very personal. Okay. It's asking me for permission, so I'm going to say yes, and I'm going to give it permission here. Yeah, sure, you can do whatever you want. I trust you. I trust you, Ben. And it's going to connect, and then we're going to do something. Now, it is expensive. Like, it's free. It doesn't cost money, but it's disk space expensive. Machine learning models are heavy. They're like 2 gigabytes or more. You'll accumulate a lot of stuff on your Google Drive, something to be aware of, and maybe free up some space so you can, okay? But here, so we have successfully done this. Now we just move down, set up the environment. All right, we click play. And that's going to set up the environment for us. While that's setting up, the next step is to download the Stable Diffusion base model. So how it works again, we take Stable Diffusion, we have this model that's already trained, we take DreamBooth, and add our images and Stable Diffusion, and it merges our images with Stable Diffusion, gives you a new model based on Stable Diffusion and your images fine-tuned, that you can then use to generate stuff with prompts, okay? So we download the base model first. We download that from a site called HuggingFace, awesome name. And HuggingFace really is like GitHub for code, but for machine learning models. It's literally the GitHub of machine learning. We need an API key from HuggingFace, so let's go do that. So if we go to HuggingFace, the AI community building the future, I love it. And what we'll do is we'll log in. I have an account, you might want to sign up if you don't. We log in and we'll go to settings. And in settings, I go to access tokens and I create one. Say for YouTube, delete, generate this token. So I have this token. I'm going to copy this and keep it handy. How's my Colab doing? All right, the environment is it set up? Let's see. It's done with the green check. Took 42 seconds. Now, let's download the model. We do take 1.5 because version 2 doesn't quite work with this yet. It will eventually. HuggingFace token. We'll paste that. I know you can see that and copy it. I know you won't, or even if you will, I'll revoke it, whatever. So HuggingFace token. We don't need this. This is not a V2 model. We don't really need to change anything else here. We're just going to now play, and it's going to go to HuggingFace and download that model. In fact, HuggingFace is a Git server. So it's going to use Git to download this from HuggingFace and just keep it ready, and then we're good. After this, we're going to, let me check here quickly. After this, yeah, we're going to train DreamBooth. So we're going to load our images. Remember the 30 pictures we took? We're going to put those in. And it's really just we're collecting stuff. We're connecting to Google Drive. We're installing dependencies. We're putting Stable Diffusion on Google. We're putting our images on Google. And then we start the training. The training will take a long time. It will take like 30 minutes to an hour. And I'll probably, I like one-take videos, but I'll probably do a jump cut there as it trains, because come on, I don't want to waste your time. I waste enough of it already. Doing long videos like my entire coding journey, which if you haven't seen, I'd recommend, link is up there. How's this doing? So it's allocating a lot of memory, apparently, and doing it. So, oh, we should also make sure we're using a GPU. So if you're not sure, go to change runtime type here and choose a GPU. It's quite important. I think I'm already doing that, so it's fine. So yeah, so we're cloning the machine learning model and it looks good. And once the model is ready, we can work with DreamBooth sessions. I think it's going to be, yeah, okay, it's ready now. Done, it says. Look at that. So sessions, a session is the name of your persisted state. So if this is a session now where we're training me, like a model of me, I'll call the session Tejas. And then I'll just reuse the Tejas session. I'll retrain that model, that my whole DreamBooth identity will live in this session. It's great. It's persistent state, even after we close the Colab, okay? So I'm going to give this session the name Tejas YouTube. Session link, I don't know. Contains faces, yeah, male faces. And now we'll just create that. Okay. This will not take too long, because it's just like making a few directories and so on. It's not going to take very long. And now we get to upload the images. It's important to know that the image names need to be identical with some unique identifier that represents you to the AI. Because person represents, you know, everyone. Dog represents things. You need a unique identifier and then the class identifier. What class of thing are you? You are a person. I hope you know that. So we'll do that. The session is created. And so now we come to uploading images. So you can upload them from a Google Drive folder, or we'll upload them properly. Mine are already cropped, so I'm not going to crop them. And if we go back here, notice it says Tejas Kumar and freaking Sydney 1. I don't like that. I want to give them a different name. So I'm going to go here and then rename these to this exactly. So A underscore Tejas Kumar, that's my unique identifier, underscore class person, okay? And that's, the underscores they represent spaces. So we'll rename this on en masse. And now we have A underscore Tejas Kumar underscore person space number, and the underscores become spaces to the machine learning model. So through this Colab. That looks good to me. So what I'm going to do is I'm going to play instance images, and it will give me an upload thingy-majiggy. And so I will come here. I will drag, actually, I will go here to wherever my directory is. Doesn't help that it has the same name, but I think it's this one exactly. And I will open 31 files being uploaded. Excellent. So now those are going to upload, and once they're uploaded, it is game time. We start training the machine learning model. We can do all of this because we're using advanced hardware on Google's computers. Like, all of the stuff we're doing doesn't exclusively happen on our machine. It happens on Google's machines. That's why Colab is so awesome. All the code that runs in the notebook runs on their machines. Free. Of course, it's free with limitations. Like, if you use too much of it, if you abuse it, they will ban you for an indeterminate amount of time. But you can always pay for Colab Pro or Pro Plus, which will just give you way more stuff. And you can pay as you go, as you grow. So it's pretty nice to piggyback off of someone else's stuff. All right, how's the image uploads doing? So the images are done. Proceed to the training cell. So now we have some parameters. Training steps is how many times do you want to go over the set of images that you're training. And you know, there's a guideline here that says number of instance images times 200. If you use 30 images, etc. I'm going to do number of instances because I want this to be quick. Number of instance images times 30 times 20, not 200. So I did 30 images. I'll do 600 instead of 6,000. I hope my math is right. So let's do. So I did 30 images, right? 30 times 2 is 60 times 10, 600. Okay, we'll do that. Seed, we can leave this random. Resolution is 512. Remember, we cropped it. This is the most important setting. Because if you don't have this on, your thing's going to have massive checkpoints. Your mod's going to be huge. You'll probably run out of Google Drive space. It's going to take too long. Just leave FP16 on. And this is also important. It's the amount of like precision you want for the text encoder. Okay, 100%. I recommend that. It works best for me. You can choose to save a checkpoint every few steps or not, or disconnect after training, just to kill your Colab connection and don't keep it on for too long. Because if you keep it on for too long, you may get banned or build more. This looks good. So what I'm going to do is I'm going to start the training. Just making sure everything's fine. Yeah, I'm going to start the training now. And it's going to train. So it says training the text encoder with regularization. There's two steps to this. It will train the text encoder, and then it will train something called the UNet, and then at the end we'll get a .ckpt.checkpoint file, which contains about 2 GB of our machine learning model, which is DreamBooth fine-tuned Stable Diffusion. We can then use that model with some type of user interface to give it prompts and generate amazing images. Let's see how this is going. So it's training the text encoder with regularization. I want to stick around actually a little bit and show you how to read the output of this thing. I think it's important to do that. If we get output today, I'm being throttled quite a bit, which is, okay, there we go. So training. And now what you can see is some output for you here. So we are training, notice the underscores became spaces. So we're training our model on a Tejas Kumar person as like the instance prompt. And here's what's happening. It's doing our steps, our iterations, and it's doing them at a rate of about 2 seconds per iteration. And it's doing 600. So if it's 2 seconds per iteration, you can estimate, how long that's going to take. 2 seconds per 600 iterations is going to take about 12 minutes, 55 seconds. And so far, 30 seconds has elapsed, etc. So I'm going to let this run, and then I'm going to see you in whenever this is over, okay? I won't say peace. That's a bit weird. But we will do a massive jump cut in 3, 2, 1... It's like 10 minutes more. Hey, you like a mobile phone? It's Samsung. I am calling Hack Sultan. Look, you are a camera. Will he answer? If he answers, will we see his face? Sultan, you know what? I think you're awesome for existing. Hello. You're training my unit. How long you gonna take, mate? How long? How long? How long? It looks like it's gonna take bloody long, doesn't it? Is it like 40 minutes? It is 40 minutes, man. I'm out here, you know what I say? I should just do British accent commentary. Carry on, carry on. Because nothing really matters. Bohemian Rhapsody, you know, I just like it's a great song. It's like if you go to karaoke at any event, he's like in my mirror, my mirror staring back at me. Justin Timberlake. Justin Timberlake. I should do a DreamBooth prompt of Tejas plus Justin Timberlake. What's up, yeah boy? All right, it's done. Look, done. The CKPT model is in your G Drive in the sessions folder. Now is actually a good time to look at what this thing actually did to our Google Drive. Let's do that. Actually, let's not do that. You know why? Because my Google Drive is private and none of your business. But I'd encourage you at this point, go look in your Google Drive. You'll be surprised. Anyway, our model's done. Now we get to test it. How do we test it? There's a web UI by A1111. And we can use this web UI. So if we press play now, it's just going to load everything. It's going to pull that down from GitHub. It's going to take our, see, automatic 1111. That's A1111. It's going to pull that down. It's going to run it with our model. And then we'll get to give it prompts and play. So we're here. We made it. Hope you're proud of yourself. If you're not, I don't know what to do. Therapy helps. But you have a lot to be proud of, okay? You're very... I mean that. I'm not even being facetious. Like, I feel like we all, you know, came from somewhere and have a story worth telling. By the way, I told mine 48 minutes long. Ridiculous. If you want to watch that, link's up there. Ooh, snap. Things be happening here, but that's none of our business because it's eventually going to spin up a web server where we can then play with our new DreamBooth trained model. That's going to be exciting. Listen, you may think I'm feeling a little bit more energetic and I'm a bit more animated, but that's just because I spent like 30 minutes waiting for this thing to load, the model to be trained, and I got very silly in that time, and now I'm just in silly mode. Okay, think nothing of it. I'm very professional. Yes, I'm suit and tie Tage. This is why I don't have a job. Anyway, okay, so let's look. This thing be taking forever. As you'll know, a lot of things do take long, which again, I like. Listen, I really, as much as you, I really like the one take feeling of my videos, but sometimes asynchronous things be asynchronous, you know what I'm saying? And we may have to do some jump cuts, okay? Here we go. So something's happening. It's downloading diffusion wrapper, I think. I don't really know what it's downloading. But we can watch this together to preserve the one take feel. I like one take. I feel like we have rapport, you know? All right, 1 more %. Come on, baby, give it to me. 1.71. And now I expect you. Oh, it's loading my model. It's the one we just trained. Oh, yeah. And any minute now, you're going to spin up a web server and a tunnel to it so we can access the automatic 1111 web UI for Stable Diffusion. Yeah. Okay, it says, here we go. It says running on local URL, this thing, connected. We're going to click that, and we're off. Now we get to play it. It tells you, hey, listen, this is a tunnel to something, be careful. Very good. So this is the Stable Diffusion web UI. I'm very excited about this. Let's actually move this up so you can see some things. And now we can give it some prompts. So let's start with, what should we do? Tejas Kumar. Let's do close up portrait of Tejas Kumar as Justin Timberlake on the moon. And we'll do something like illustration, 8K, high resolution, art station. Just give it all the buzzwords, you know. Whatever, that's fine. So there's some tuning parameters here. We'll talk about those in a minute, but just to give us something to go off of, let's run this and see what comes out. So I click generate, and let's see. Again, everything takes longer than you think, but this takes just a couple seconds. It takes like 5 seconds probably at the max. And now we should have, oh, who's that? That's Tejas Kumar as Justin Timberlake. I kind of like it. Let's generate again. So I'm doing 1 by 1, but if you increase the batch count, you can get, you know, 50 at a time if you want. I find the time investment, oh, wow. I'm so delicate. I find the time investment for that a bit sketch. And so now this is kind of nice, actually. But let's talk about, wow. I really like that one. Let's talk about some of these parameters because they're interesting. So sampling steps, this one here, is how many times the machine learning model goes over what it has drawn and improves it. It's the kind of like the resolution of it. So if you do low sampling steps, you'll get something kind of unfinished, low res. The higher the sampling steps, the higher the like fidelity, the quality of your thing. That's really important. The sampling method is how the samples are taken of the image, the reference images and things, I think. This is of course the resolution of your image. You can change the width and height as you want. I never use these, so you're gonna have to ask someone else about them, but batch count is how many images you want, and batch size is how many images you want to process at a time. This is the guidance scale. It's classifier free guidance scale, and it's essentially how creative you want the model to be. If it's low, that means you're not guiding it at all, and it's going to make up whatever it wants out of the diffusion, right? So like let's actually set that to like very low. We'll generate something, and now what you'll see is it's not going to adhere to the prompt at all. It's going to be some wacky, you know, oh, that's like Jared Leto. And if we take this up to an extreme like 10, it's going to literally give me a close-up portrait of Tejas Kumar, Justin Timberlake on the moon, etc. So it's going to literally like adhere to the prompt more. Come on. Come on. You don't want to? Really? Oh, there we go. Wow. So you see that difference. The last thing I'll talk about is the seed. This is probably really important. So -1 on seed means start from a random starting point. Again, listen, I'm not a data scientist. I'm not a machine learning engineer. This is just plain English for those of us who do it this way. If I was machine learning engineer or whatever, I'd be having a very different conversation and a very different video. This is for the everyday people, okay? So seed, to me, I'm wrong, probably. If I am, drop a comment for the sake of truth, for education, etc., even for me. My understanding of the seed is it's a starting point from which to generate the image in space. -1 means random every time, but every like image has an address in the neural network. That is the seed, and you can generate images based off of seeds of other images. But keep in mind, this is a bespoke neural network, bespoke machine learning model that we just trained. So even at that address, it'll have mutations. It'll be a little bit different, and we'll get our own version of things. Okay, so that's how you do it. Let's do one more prompt, and then we look at how we can increase the quality of our prompts. So instead of close-up portrait, we'll do full body portrait, or let's do wide angle portrait of Tejas Kumar in the style of Borderlands, or let's say in the style of Fortnite. I'm really curious to see what happens here. We'll up the sampling steps a little bit as well and generate away. I really don't know what's going to happen, but I'm really curious. And sometimes it's going to be bad. It's just how it's part of it. This machine is a machine after all, doing its best. How are we doing? Oh, that's actually not too bad. What if I remove the illustration piece from the prompt? And note, like this, if I fine-tune the sampling details, like if I increase the sampling steps here, I'll probably get, you know, higher quality of my face on that thing. What do we have? It's no longer, oh. Okay, I don't know how that's quite Fortnite, but we'll give it that. So now the question becomes, great, we kind of wrote our own prompts, etc. How do we get inspired? How do we see cool styles that people have done and copy them? And this is really cool because there's a website called Lexica that does that. It's like the Stable Diffusion search engine, and you can look at all of these things generated from Stable Diffusion and then generate your own based on that. And let's look at how we do that. I like this muscly guy. Let's give me muscles. So this is the prompt here. This is the seed. Remember we talked about the seed, like the starting point. So this is the seed, the guidance scale, the CFG, and the resolution. So using these, we should be able to get something similar. So I'm going to copy the prompt back to Stable Diffusion, paste the prompt, but instead of portrait of Lucas Vasquez, I'm just going to do me, my identifier. And this all looks good. We will then go back and copy the other stuff. So Lexica. The seed I want, we'll put the seed in here. What else? The guidance scale and the dimensions, 13 and 704. So we'll do, where are we? We'll do 704 for the height, 13 on the guidance scale. Okay. And again, like the sampling method and stuff, we don't know. We're just going to wing it and see what happens, but I'll generate and we'll see what we get. And again, I could generate like 2 images, 3 images, 4 images at a time. I'm just doing one by one because it's faster. Here, let's take a look. Come on. I believe in you. Oh, I'm a woman. I'm not gonna lie, that's pretty nice. Now, no, if I generate again, I'm going to get exactly the same image, and that's because I have the same seed and nothing has changed. The prompt, the seed, the height, all of it's the same. And so it is deterministic, and it's always going to give me the same image. So I need to now change something to maybe make myself male. And I'm going to just put male here in the prompt. Another important thing for you to know about the prompt, I need you to pay attention to this because it's very important. The prompt is weighted from left to right. So if male is first, male is like the most important thing in the prompt. So you can fine tune the attributes you described separated by commas in your prompt by moving them around. If male is at the end, to the model, it's not going to be so important, and maybe you'll be male, maybe you won't, but the stuff at the front is more important, okay? That's really important for you to know. So let's go back here. Oh my word! Ooh, boy, I love this. Hey, listen. And now that we have this, we can maybe change the sampling method and see what we get, but this, whoo, that's, listen, I feel like I'm a hottie in the AI world. Anyway, come on. So yeah, this is how we play. Now we just play. We just keep playing as much as we want. In fact, we have a trained model, so we can do whatever we want. This seems to be working. I'm happy with this. After this image loads, we'll go back to. Oh, dude, Wow, can I save? I'm saving this image. That's amazing. Okay, great. So this works. Let's go back to this notebook. We can kill the dev server. We can be very happy that our model worked. And now we can do some finishing up stuff. We can save this model to HuggingFace if we want to. We just need an API key with write access. But this model is already in your Google Drive. You have a .ckpt, .checkpoint file. It's there. I have this saved now. I'm happy. And I can retrain it as many times if I want. I can come back here, go through all the steps. And the training step, which was here. Wait. No, that's the testing step. Sorry. The training step, I could just check this box after choosing that file, and then I can retrain it so it gets more and more trained over time. It gets better, okay? Lastly, now that we have a model, we can also play with Stable Diffusion locally. So I have an M1 MacBook Pro, and there's an app that I'd like to show you that doesn't depend on Colab, and I can just run locally whenever I want. It's called DiffusionBee, this thing here. You can download it from macOS. It's completely free, no strings attached. And I have it here with a model that I downloaded, that I trained. So we can just, let's run that. So we're gonna go to DiffusionBee, and it opens up. It looks like this. I'm gonna maybe change this tab so it doesn't, maybe we'll do a different tab. Okay, that's nice. And now it's going to open up and it's going to load a default model. But what you can do in DiffusionBee is you go here, you go to settings, and you can choose your own models here. So I have the Teju model that is me, and I will actually choose to use that. So I'll go here, pick the Teju model, and how many images do I want? This time I want 5 images. 512, 512 is fine. Steps, I want them to be not that clear. I just want to test it out. Guidance can be this much. The seed can be random. All right, and let's put that same prompt in here and we'll get very different results because it's a different GPU, it's a different setup, it's a different everything. Also, I have a different identifier. I'm not Tejas Kumar in that. So we'll see what we get. I am actually, I forgot what, I'm like Teju, something like this. Yeah, I think that's me. I don't know, let's see what happens. So we'll generate. See what happens. So it's going to take some time for the first load because this first model load, it's just going to load into memory, and then subsequent renders are going to be faster, kind of like React. But once it loads, we'll be good. Let's wait for this. DiffusionBee is pretty nice. It's not going to give you the quality as, you know, something on a beefy GPU, but it's still fun to play with. So it's starting diffusion, and we will have a progress bar very soon of how it starts generating images. All right, here we go. So it's doing, okay, well, point that. Wow, it was so fast. And here, so we have some images, but notice I'm like really prominent in this, you see, because I'm here, I'm weighted here. So let's actually remove this. Let's change this with person, and we'll run it again. So we removed my like unique identifier from the prompt locally, and now let's see what we get. That's much better. How does that look? That looks like a bit like Jason Statham, but it's okay. Yeah, not too bad. Also not too good, but does it look like me? None of this looks like me. So we'll add myself to the prompt, maybe here. Some identifier here, something like this. And again, that's a different model with a different identifier. Remember, the first one was Tejas Kumar. And now, how does that look? Ooh la la! That is a slice of beefcake. And notice, oh dang! And notice the quality is not so good. So I'm going to take this 8 and now double it, the sampling rate, the steps as it were. And now we'll generate. It's going to be a bit slower because it's more iterations, but we'll get a higher quality image. Let's see what we get. Ooh, okay. I mean, there's no muscles, but it's a start. Let's see what else we get. Where are the muscles? Last one, and then we're calling it. Okay. Something went very wrong, but that's okay. You know, you play, you iterate, you learn, and it's good. So that's all I have for you. I hope this was valuable. I hope you learned something. I hope you're able to go and create beautiful AI art. Let me know what you create. At me on Twitter with your images, or leave comments here with links. And also anything I either missed or anything you want to clarify, or any further questions. Listen, I'm all about the conversation. So hit me up on Twitter or leave a comment below. Until then, that's been it. Thank you for watching, and I'll catch you in the next one. Peace.